Hey everybody! So today we got something cool to look at. I apologize for the lack of content lately, but to be perfectly honest, I've only had a bunch of cleanings and color wheels and really burnt connectors. There's really no point in wasting y'all time with watching another BenQ having its color wheel changed or an Optima with a bad connector. So I've been holding out for a little more quality and a little more useful content, and I happened to meet a really nice guy named Drew. Everybody thank Drew in the comments for me. He contacted me on a Facebook group that I'm in, and we worked out a little deal where I got my hands on this NEC P502HL-2 1080p laser projector. We did a little bit of wheel and dealing. You know, I sent him a couple truckloads of color wheels, and he sent me a couple truckloads back of connectors, and we went back and forth, and I ended up with this projector. We didn't really exchange truckloads of stuff, but I thought that'd be fun. But again, please thank Drew in the comments. Good dude. So this has an overheating issue, a weird overheating issue. It doesn't just shut down right away. It runs for a little while and then shuts down. So I haven't really done any actual troubleshooting yet. I did plug it in once just to make sure it turned on, you know, survive shipping and all that stuff, and it did come on. It does work, but it does also shut down, and then it flashes the status light 4 times. So if you look in the manual, if you see that flashing amber 4 times, pause, flash 4 times, that's a fan error. The other thing I did, just to be safe, is I plugged into the LAN port and I hooked it up to the computer, looked at it through the network, and sure enough, when it failed, I got a fan error. And I decided let's really dig into this and see if we can figure it out, because I decided I'm going to sell my Christie. My Christie's not true 1080, it's 1280 by 800. But it's 7,000 lumen, and the picture's really nice, even with it downscaling. But this is 1080, so, you know, this will be way better. So I'm going to sell the Christie. I'll put an ad or a listing in the thing there if you're interested. You got to be in the U.S. or willing to cover shipping to where you are. Won't be cheap. It's a big projector. But anyway, let's go back to this one. So what I want to do first is we want to open this up, and being NEC is really nice to work on. So let me move the camera and give you guys a better viewpoint. There's actually not a ton of screws in this. We have 1, 2, 3, 4, 5, 6, 7, 8 screws. Now I took one out so I can show you guys something you got to pay attention to. This seems to be with all NECs. When you get your screwdriver, make sure you get your smaller one. I think that's a PH1. Yeah, I think that says PH1. I can't really read it now. But this is a PH2. You can't use, well, you can kind of use it, but it'll cam out and strip it. The PH1 locks right in. It's got those really tight threads. These might even be JST. I think, oh, maybe not. I think JST has that little dot to indicate that they're JST, but this fits really well, nice and tight. So let's pop the rest of these out, and we'll open it up. Alright, so this should, there we go, pops right off. I love NEC stuff. They really make it serviceable. I've also noticed, and this isn't comparing, like saying one's better or not, but I've noticed the Japanese engineering methods are very different than Chinese engineering methods. I've noticed Japanese tend to use way more screws. Maybe they're needed, maybe they're not, I don't know. I'm not really an engineer, so I can't say. But I've always noticed like NEC, Panasonic, Sanyo, even Epson, they're almost over-engineered to a point. Epson I can't stand. I actually want to talk trash on Epson, but they do, you know, they make nice brackets and everything, and they're definitely built well. They're just not very repairable. Panasonic and NEC, on the other hand, very repairable. So what we got going on here, let's do a quick tour before we really start digging in. We'll start on the back. Look at our jack panel. Power cord, obviously. Monitor in, monitor out. You know, VGA. Have some audio. That's pretty cool. Dual HDMI. Ethernet for HD base T. This is kind of like a Crestron thing, if I remember correctly. Uses networking, but it's not like LAN stuff. It's more for video. Got USB. I think this can actually play pictures, like do a picture, scrolling picture thing, possibly play videos through here. I seem to recall the menu having something like that. I do know this projector supports screen mirroring or Miracast. It also supports remote desktop, which is pretty cool. LAN port, of course, normal network control. I actually tried that already. That was how I verified it was shutting down. Audio, old school audio. And I thought this was S-Video at first, but that's 3D Sync. So that hooks up to the IR thing for glasses. It's cool seeing these, though. It's kind of like a Swiss Army projector. You can plug almost anything into it. We don't have a component or DVI, but we do have HDMI. So, and this is where wireless goes. I actually don't know. I don't know if this has a... No wireless adapter. Wireless adapter would be in there. No wireless adapter. I might have one out of another projector, another NEC. If I find that at some point, maybe we'll put it in, but I'm not super stressing it. I plan on, if I fix this, I plan on hooking this up at home. It'll be hardwired, so it won't matter. So we can look at the insides now. We have main board, obviously. Some ROM. We got a, does it say DLP on it? Yeah, there's a DLP chip, control chip. And Orion, oh, Epson, interesting. See that? Epson, very interesting. And Valens, this is probably a network controller because it's going to that ether base T. There's the transformer. So there's really not a whole lot to see on this side. I'm sure there's more underneath. We're really not worried about that, though. Then we'll go over here. We have exhaust fan for a heat sink. The laser source is right here. Give you guys a little better view as I kick the tripod. So right here we have 4 laser modules. They are UV laser modules. I have this module here. This is from Oxopo. I'll put a link to them down in the description. If you guys happen to need replacement laser sources of this type, the UV type, they let's see, they're 450 to 460 nanometers. So that's UV, ultraviolet. That's the source for that. This, if you look kind of down there, you can see that gold. That's this. So there's 1, 2, 3, 4. I think these are 50 watt modules. So there's probably 200 watts roughly, give or take, of laser diode in there. They all fire up fine. No problems with the laser diodes, which is great. And then we have our cooling for them. There's heat pipes drawing. You can see the heat pipe here comes off of that set of modules, and that's cooled here with the radiator. This one has the shroud over it. This one we can see a little better. Same thing, heat pipes come off that side. This is a heat sink or radiator with the fan behind it. Then in the front, that's our little display panel that has the flashing lights on it. This is a speaker right here. This is an exhaust vent with a temperature sensor. And then, let's see, inside this block, I don't know what the technical name for this is, but this is a, I don't know what you call this sub-assembly. This has the phosphor wheel and the color wheel in it. Over here, I think this is the color wheel wire, and I think this is the phosphor wheel wire. Phosphor wheel creates the white light from the UV, and then the color wheel gives us the rest of the colors for everything. So the rest of it, then we'll slide it over. We have our lens with focus and zoom. Then we have translation adjustments for moving the lens up and down, side to side. The DMD is, I think that's back here. Yeah, I see the DMD card under it here. So we have the DMD back here. The light must come in and bounce around to get to there. And then we have two more fans on the back. So we have 1, 2, 3, 4, 5 fans, as far as I know. And looking at the connectors on the boards, that seems right. So we have 1 here, this one, 2, this one goes inside this. Okay, 3, 4, and 5. Wish I could see this fan though. Watch this be the problem fan. Yeah, it does go inside. Look. Right there. See that wire, that white wire? That's the fan going in. So one of these fans is acting up. Don't know which one yet, but hopefully we're going to figure it out in the next few minutes, because I'd really like to fix this thing today. Let me spin it around and we'll fire it up. Before we fire it up, some of you keener eye folks may have noticed a switch over here. I have a little rocker switch, momentary switch kind of thing. And inside the lid, got a plastic actuator nub dealy right there that pushes down on it. This is our door switch, like in a normal lamp-based projector. This keeps the laser diodes from coming on when the cover's off. And you know, most people, you don't want that to happen. We want that to happen. So the wire goes over to here. So we're going to unplug that. And then I happen to have a wire that I harvested out of another door switch that, it's close enough. And it's a shunt jumper, you know. See, plugs in. Now I don't have to worry about finding something to hold that switch down. So let's grab the power cord and see what happens. Alright, it is in standby. Here we are, fans are coming on. They look like they're all on, the ones that I can see. We have a picture or something. There's the color wheel. We're at the apps menu. Oh yeah, that's where I was messing around last. Here we are. So if I go into the menu, I think it was, yeah, test pattern. So there's white. I want to heat it up. Let's get those fans working. And then let's look at my meter. And then let's see what a fan tests as. Oh, I don't need that. Let's see. You guys can see that a little better. There we are. So I'm going to go on the tachometer lead, or the fan status lead. Oh, no, millivolts, not DC. So let's check the, this is the status wire. This is actually a square wave that we're seeing the average of. I'm just looking to get kind of a a baseline. And about 1.7 sounds about right. I'm going to check the two fans on the radiators for the laser diodes. And they're also showing about 1.7. And we'll check that little one inside. Oh, that's weird. Alright, so the one that goes inside is coming up at 2.9 and creeping. If that's going up, that means the square wave's getting longer and the pulses are getting shorter, meaning that the fan is spinning slower. Now, on my meter, I can also go to frequency in hertz. So here's the this fan. We got 140 hertz roughly. This fan, 140 hertz roughly. Oh, and it just cut out. Oh, see, this is the fan going inside. Wow. I think it's this fan. I watched that just drop on me right when that picture went out, and the rest of these were still up. Can I fire it back up yet? Let's see. Let's see what we get on this one. 112, okay, 114. Let's go to the radiators, 105 hertz. This one, 110 hertz. And back to these guys again. We got 140 and 140. Let's go back to that front one again. I want to see. Yeah, see, that's not right. 60, 56. Just dropped enough, and that fan stopped. All right, let's turn it. Well, let's turn it off. There we go. Okay, so I am very confident. Plug this. I'm very confident this fan is the problem. This is where we're going to investigate. So like I guessed, I'm gonna have to get inside here, which means what? This has to come out. That maybe has to come out. This definitely has to come out. We got to get to where that fan is. Let's open that up. Let's move. Let's see, that's the front panel. This is the keyboard connector, or sorry, not keyboard, display for the LEDs and stuff. Oh, I should have showed you guys the flashing LEDs. Well, just pretend it was flashing 4 times. Because I'm sure it was. Because it flashed 4 times when I first plugged it in to see what it would do. Surprised how fast that fan acted up though. See, it goes down. There's that wire. It's going down underneath that heatsink. Let's get these out of the way. Yeah, we need to get in here, so this has to come off. Can I get that off without taking the main board out? We can take that screw out. Maybe these. Let's see. I really don't want to have to take the main board out. If we can finagle this aluminum chunk out of the way, that would be pretty sweet. Do I have any screws hiding back here? Let's see what this feels like. Feels loose, but I kind of feel like there's one more. Yeah, there's another screw, but it does look accessible. It is down here. Yeah, that came right out. Like I said, NEC is very repairable. Let's unplug that speaker. It's interesting that speaker has 4 wires going into it. I wonder if they're sending stereo, if it's a dual voice coil tiny speaker. I'm not going to take it out. But see what I mean? We got 4 wires, but there's only a single speaker. I bet you it's a dual voice coil. And this screw is just holding that clip in, so we're going to leave that. So can I let me look under there, make sure I'm not going to clip the color wheel or something. No, looks okay. Let's get these these wires up out of the way. I see the fan, but this board is flexing a little too much, so I'm going to take 2 more screws out. It'll give this board just a little more flex, safe flex. There we go. There we are. That's kind of nice. There's the problem. This guy right here. It's either getting hot and melting inside, or you know, getting hot and overheating and shutting itself down, or the fan's just worn out. Now this whole area does get pretty warm while it's running. Yeah, this thing did get pretty warm. Something I think went. See that? Right there? We'll look at this in a moment. Let me just put these screws out of the way. And let's peek in here. There's the phosphor wheel. So that little rim is phosphorus, or a phosphorus material, that gets hit by the UV light and that fluoresces white. Then it bounces around through a bunch of mirrors and whatnot in there, and then the color wheel. Right here. It's a big color wheel. Spins really nice too. So there's, like I said, there's a whole bunch of lenses and whatnot inside there. And then that eventually ends up coming out of the, lens onto the screen. So let's look at this fan. Figure out if I have one or if I'm going to buy one, and see if we can get this fella up and running. So this is a NEC brand fan. They're pretty common. I may have one, but being that it's located where it is, I think I might actually buy one instead of putting in a used but good fan, because it is really kind of a pain to get to. What I want to see is why this has this like heat burn mark over the this chip. This thing got hot. I bet you this is the problem. I'll bet you the status reporting circuit went bad. Come on, sticker. Let's see the rest. No, all I can see is that chip. So this chip probably got really hot. And in theory, if I had one, I could probably desolder it and put a new one in, because this fan does have, yeah, this has actual ball bearings instead of just the, those oil bronze sleeve bearings that a lot of these fans use. This one actually has real, ball bearings in there. That diode looks a little funny too. I think I'm just going to get another fan. So let me get another fan, and then by the magic of video, we'll put this back together. Hopefully this does it. We had a hard time finding the exact fan. The part number on here, this D07F12B151, also points to a Toto brand fan, not just a NEC. The vendor says this one should work. Physically, it's the same, but the thing I'm worried about is the status wire, the yellow wire. Now on this one it's red or white, and on the other one it's yellow. I'm worried that this is a stall indicator only, meaning it won't report the RPMs. But we're going to try it. The technician is actually pretty good. He's steered me pretty well in the past. So let's see, I think we want to go, wait a minute, so like that. Oh wait, no, it's upside down. So blow it this way. Yeah, we're gonna blow it that way. Because then once this is on, that will force the air down into the phosphor wheel. Because the phosphor wheel gets pretty hot, because that's where the laser initially gets converted. So this will go on here, it'll suck air in, it'll pull it up through the color wheel opening, pass across these little veins, these ribs, to pull some of the heat out, and then blow it down across the phosphor wheel. So I think I really would like to try this without putting the cover on, but I have a feeling that'll be a bad idea. I think I stand to cause more problems than I'll solve if I try to test it that way. So what we'll do is we'll set that metal cover on, and then I'll probably put in this screw and that screw maybe. Come on, there we go. Excuse me. Get the okay, so we'll use, I think it's these two. Alright, here we go. Oh, no, this tip is the wrong size. There we go. Have the wrong size tip. Alright, one. And remember, these are the black screws. Okay, those two are in. Push the DMD back down, so that's connected. I'm going to put this screw in here to hold that board down. Actually, I'm going to put it in here. Because I had to unplug the DMD card back there. So then we'll take the fan. And the wire order was the same. Would have been like that. So positive, negative status, positive, negative status. Then we have this. Come on. There we are. And that's a temp sensor. So speaker. Plug that back in. We have our controls on the side. Alright, everything. We have our bypass switch. Alright, let me get a power cord and let's see what happens. Magic. We now have a replacement fan. Good old time electronics coming through once again. Oh yeah. That looks like the right fan. NIDEC D07F 12B1S1 21B. That must be a different batch number, but this will do it. The wire will be routed. Let me unplug this low voltage or front panel wire out of the way. Move that front panel wire out of the way. And remember, the opening goes up. Let's put these in, then we'll route the wire, we'll set the cover on. We should be able to test it. Alright. Just move those wires out of the way, it'll make this easier. You definitely need to be careful when you set this down on this side because of that phosphor wheel. You need to make sure you don't accidentally clip the phosphor wheel and bend it. You'll feel everything kind of line up. There's alignment pins right there. Let's put those guys in. Oh. Well, that's weird. Hang on. The end is different. Now the wires are right, it's just the end's a little different. So we're going to have to splice those, but that's alright. Let's get these screws in, and then I will make an adapter. I'll show you what I mean. I'm going to see if I have a main board that has a 3-pin receptacle for that, and we'll remove that. And then we'll solder these wires to it. We'll just make a little extension adapter. Finding this exact fan was a little more difficult than I expected. A lot of people had ones that were similar, but not close enough. Now we got a little adapter, and we can hook that up. That goes there, and that goes there. And then I can put it in there. Actually, I'm going to put a piece of, let's put a piece of shrink tubing. And I'm not actually going to shrink it. There we go. Just to keep it from shorting out on things, you know. So that's good. Let's set the temperature sensor back in here. There we go, like that. That wire goes under here. Right there. Speakers. And of course, the display on the front. There we are. Put that in there. Alright, so that's enough for testing. Let's push that down. Just drop a few screws in to hold that DMD connection in place. Okay, so let's spin it around. Still have my bypass tool in there, yep. And back you guys out a little bit. There we are, power. See if it comes on. Oh, I got phosphor wheels and color wheels. Good sign. No light yet. Oh, something else. One, two, three, four. I think that's a fan. Alright, so I did a little trick here. The fan's still not coming on, or the fan is coming on, but the projector still isn't starting right. So I actually ran the pin out of the back of that adapter that I made over to the tachometer lead of this fan. I figure that'll be a good test to see if what we have going on here is a defective new fan, which is kind of where I'm leaning. But let's see, let's get the scope out. Alright, let's fire it up. So we do have PWM now, and I have a picture also. We have an image coming up. Oh, wrong way. See, so we do have a picture. The fan is working, it's cooling. I could even probably run it like that, but I'm not going to do that. We're going to get the right fan and get it figured out. So let me shut this down, and then I'll be back once I get another fan. We're going to give this fan a shot again. This fan I tried at some point. I don't know if I actually recorded it the first time or if I was just testing it. But the original fan right here, I actually pulled the guts out of, which are right here. There's the guts minus the coil. I pulled that out because I wasn't sure about this chip right here. I was trying to get information on that fan control chip. It's marked 720 with an M maybe? I think that's an M. 720. It's definitely a fan control IC because on my latest replacement, I've actually gotten two fans for this. This fan right here has a chip I can look up. This is definitely, it says it's a single phase fan control, and pin 10 bottom right there is lock high and running low. So when the fan's spinning, that goes low, that far pin, and when it locks, it goes high. I need a PWM output. Now I did read that pin 9, the one next to it, does give you PWM output. So first I tried to take this apart to get to the board, but unfortunately when I took the washer off that holds the shaft to the bearings, it went boing and flew away into space. And it's probably floating around up by the moon by now. So unfortunately I couldn't do that. However, I had this fan which had the same chip in it. So I took the coils off of the original one, unwrapped a little bit of the enameled wire, cut the trace that went to pin 10, because that trace ran directly to the fan lock lead. Actually, I'll show you on the other fan. So that ran directly to the white wire. Told it did say that it had a stall. So I cut the wire going to the trace going to pin 10, and then soldered a tiny little jumper from pin 9 to the fan lock wire. So we should get output now, PWM output, if the data sheet was right. Hopefully those pictures were up long enough for you guys to see what I did. That was it was a bit of a chore because I couldn't take the board out. I did not record it because I had to use my microscope, and that doesn't record audio, or if it does, I haven't figured out how to do it yet. But it's done. That's the important part. So let's see if it works. Let's put this cover back on. Let me just lift up on that. See if we can. I'm going to try to get this under without knocking the the foam out of the way. Let's plug it in. Everything looks good. Got a picture. So that means that fan's spinning. Look at that. That's what I would expect to see. I think I might have fixed it. It's a brand new fan, so changing that seemed to make the difference. So that's great. I'm going to shut it back down and put a couple more of the screws back in, and we'll try it again. This one, and then this one. Then we'll put the screws in that hold that in. Get these fellows on top first. Good. There we are. All right. It's going to go through there. Plug that in. It's good. It's in there. That's good. Will that fit in there? Nope. Okay, so they're in. Let's go under. There we are. Then the black screws that go in this thing. And then one more over, where is it? Right here. Blocking everything. That should do it. I think we're good here. Let's move my little... Actually, we're not going to disconnect my bypass switch yet. I'll show you what I mean. That way. There we go. Alright, that actually dropped right on. Lens shift control looks good. Alright, let's plug it in and try it. Make sure the lights are on. They are. I'm just going to keep my hand on top just so that switch doesn't accidentally lift off. Yeah, that looks good. Let's focus it a little. Zoom it out. I like that. And it's got the mirror cast on it. Man, I have a Sony at home that I love, but I'm really thinking about trying this fella out and comparing it to the Sony. Now, let's shut her down. And we'll put screws back in. Got her up and running. Have it plugged into my laptop, and I have my YouTube channel plug of the week, which I will show you now. This channel is UAEOD. It's a fella from England named Harley. He's the guy whose hand you can see right there. He runs a team who is demining parts of Ukraine, which is awesome. If you guys have any spare money, I put a link in the description to Harley's channel. Charlie could use some dog food there. Take care of Charlie. And also the other folks on his team, they need, you know, winter gear, food, vehicles, just stuff. You know, they're doing this all on a volunteer basis, which is pretty amazing when you think about the risks they put themselves into totally just to help people out. Big supporter of Ukraine, so want to help them out as much as I can. So again, check the description. I'll have a link to UAEOD. Give Harley a shout. Tell him I said hi. Doubt he remembers who I am, but I just think it's cool what they're doing. So if you guys have any questions about fixing your NEC P502HL-2 laser DLP projector, go ahead and put it down in the comments. If you want faster response or faster help, check the community page and look for the link to the Facebook group that I admin. There's a bunch of projector professionals in there, so any of us could help you out. If you don't subscribe to my channel, think about hitting that subscribe button. It helps me out. It'll make YouTube do the algorithm thing and all that fun stuff. But most importantly, as always, thank you for watching.